Before we jump into these topics, let's quickly look at what we have learned in our previous session. So let me just go back to the previous session charts that we have seen latency, and we have seen what is the meaning of latency and what is our goal and how usually we calculate the latency. And we have also seen some example where different hardware devices or network consideration that we have seen and how much 1 MB of packet is transfer from memory to you or from SSD, from HHD or network of speed 1 gigabyte per second and how much time it takes. So latency is the one of the most important factor when we design a system. Okay. Then we looked at throughput, that what exactly is throughput and how we measure throughput. And we also seen some of the example, like when we talk about network speed, 200 MB per second or 1 GB per second. So we have seen some of the example. And to understand it better, we also look at one of the analogy of pipe, water pipe, where we have just seen the difference between latency, throughput, and bandwidth. Especially when we talk about bandwidth, we get confused with throughput. So we have seen what is bandwidth is the actual size of the pipe, but the throughput is the actual water that flows through that pipe. So there is a difference between it. So, and also we have seen the latency is that water going from one end to another end, maybe in a second, maybe in a minute. So that will be the speed of water. So similarly, the data is also we can measure in the same uh, way that how quickly data can be transferred from one location to another location. So this is some of the example and analogy just to make our mindset clear that yes, this is how we can also look at the bandwidth through throughput and as well as latency. And today what we are going to look at is some more concepts. These are also important. So, and these are somewhere related to availability. So we have seen availability definition is the time a system remains operational to perform its required function in a specific period. And our goal is to keep our system highly available. So what we have seen is whenever we visit any website or whenever we try to open any app at any time of the day, the system will immediately open up and it start responding to you. Like if you open Facebook, you'll able to see your Facebook page, the feed that we get on Facebook. You can go and visit to your friends' page and all. All this activity can do anytime in a day. But there are possibility that sometimes the availability go down and your system means you will not able to access that system, the feature available through that system. Maybe the web page will not open. Maybe you will not do any perform any operations on that system or any mobile app. So that is see, even though we have seen that availability is measured in 99.9999, the availability nines that concept that we have learned, but it's not possible to achieve 100% availability because it is first thing it is too costly to achieve. And second is whenever a system we are designed, there are possibility of hardware failures, software failures, network failures. So there are chances of these kind of failures because of which the achieving availability like 8 nines or 9 nines, it's not that easy. Okay, but looking at availability and we want to make our system available for our users, some of the concept we need to keep in our mind that how we can make our system available. So there is one more concept called fault tolerance. A system should be fault tolerance. So what does it mean? So here I just put a book definition. We call as fault tolerance refers to the ability of a system to continue operating without interruption when one or more of its components are failed. Okay, so let's divide this fault and tolerance into two parts. First of all, we'll understand what is fault. The fault is actually a failure of any of the component. Now, looking at our diagrams, if any of the components, suppose on the top right hand corner diagram, if web server is failed, then your system will not work because we have only one web server, we have only one database. So that is a single point of failure, right? And if that component fail, your system will go down. There will be downtime or interruption in service that you are providing to your user. So that will be down means your system is not available for user to use. So in such cases, we have to see to it that even though there is fault, even though any of the component of your system is down or is failed, still your system should respond to user's request. So how we achieve that? We already seen in our previous sessions that we used multiple web servers under auto scaling group. It is mentioned on the right hand bottom diagram. And also we have seen the database layer or data layer in which we have seen multiple slave database and master database, and there is a continuous replication that is happening. So just imagine if any of this web server which is under auto scaling group is failed for some time, the load will be on the other servers. Suppose there are out of three, two servers are down. Maybe for some time, the server three, suppose it is not mentioned here, but I'm just mentioning here that if there is a web server three and web server one and two are down, then all the load will be on web server 3 for some time till the time the other two servers are not restored. So there are chances here. I mentioned there is a performance degrade. So that performance degrade is because now there is only one server available to serve the user. So that's why the performance will go down for some time. And as well as there will be some kind of latency will be there because the load is fully on one server. So definitely latency will increase. The server will take time to respond. So that is for some time, and maybe once the other two servers are available or restored, then again every operation will be normally react to the user's request. So but fault is there is no downtime. Even though there is a fault, the system is still responding to user. Maybe there is a delay in request, performance degradation. There will be little, I'm not saying high means very high latency, but there will be latency delay. So user will get response little longer than expected. So that is okay, but still system is giving response to user. It's not that system is completely down where user is not able to access any of your services or your website or your app. So this is called fault tolerance. Fault is, I'm just repeating, fault is the web server or database, any of those components are failed, but still you're getting the service. So that for, I mean, the failure of component is fault, but even after that, your system is providing the services. That means it is tolerant. It is giving you service. There is no downtime. The service is still available, even though there are chances of delay. That is called fault tolerance. So you should understand the meaning of what is fault and what is tolerance. So here there is no downtime. The service is still available. Okay. But moving on to the next topic is resilience. So let's look at the definition. Resilience is the ability of system to withstand or recover from failure, disruption, or stress without significant downtime or loss of functionality. What is what is it saying that, for example, out of these two servers in auto scaling group, suppose all servers are down, okay, and your system is not available. See, resilience comes into picture when your system is actually down, your service is actually not available for user. So when a system is down or system is failed, which is not giving you the service that is you're looking for, in that case, the time it takes to come up again, like again start itself and provide you the necessary services, it's that time is called the ability of resilience. See, the failure will definitely occur in all systems. It's not that possible that there are no failures. Failure will be there. But to see to it, first we have seen the fault tolerance to see that if any of the component goes down, other components will take over and the system will be running. But still, there are chances that system will go down for sure. But then there is the ability of system to come up again. Maybe all servers are go down, then the system will again reset, system will restore again. So that time from the failure to again coming back to the normal conditions when user was able to access the service, that time is the ability of resilience of the system. System is able to recover from that failure. So the time is necessary. So system, even though if it is failed, if it is quickly come back to give you what is the service that you are requested for, that is called resilience of the system. So we have to make sure that a system is highly resilient. System should have that capability that it is should be fault tolerant. and it should be resilience. Resilience, again, I'm repeating, resilience is the system after failure, how soon it can come back to its normal operations. So that is what the resilience is. All right. Any question on this?
So the time of resilience and that period is means uh,
Yeah. See,
okay.
that time is, if you're looking for the how much time it will take, it all depends on your system. It all depends on maybe if you're using a cloud provider, how much cloud provider can quickly restore your system. See, there are chances maybe situation like um, a catastrophic event like flood or maybe fire or maybe something else. Your entire data center is down. So moving from one data center to other data center will take some time, maybe minute, maybe 5 minutes. So that time is no one can do anything in that case. But the time it quickly move back to its normal working condition, that time it depends on system to system. But that time we need to consider while design the system. See, it is not in our hand that how much time it will take. Maybe you have to uh, have a service level agreement with your cloud provider that how soon it will get restored. So, and again, there is a cost involved. But it all depends on how you design your system, how the cloud provider providing you have these components, web servers or database on their in their cloud services. So how your agreement is decided, it all depends on that. But definitely that time is as less as possible. But again, there will be cost involved in it. We cannot measure the time. We cannot decide uh, in advance. But definitely that is needed to understand that if the system goes down, it is more important in how we can restore it back or how we can provide you services, even one or two components. So that is the consideration we have to uh, consider when we will create a system or we will design a system. See, to create a fault tolerant system, there are components available like auto scaling group is there, multiple data. So these things we need to keep in our mind when we will design a system. We should see to it that we are using auto scaling out. We should see to it how we will use more number of users, web servers in our systems or databases in our system, so that the system will become fault tolerant. And resilience is a condition where system will definitely fail. Maybe a network issue, which we cannot do anything on that. Maybe a web server uh, under at auto scaling group is failed. Maybe all web servers have failed. Maybe database have failed. So how you are designing a system to see to it that okay, web server, how we can restore it back quickly? Can we have a replication? When we discuss about multi-region replication, so that comes into this picture. Okay, when a complete data center is down, then how we can move, how the data has been replicated. So all this consideration will be there to make sure that our system will become resilient also, and the expected result, the data that is stored from user to the database, is already replicated to the other region. So that all consideration should be there when we will design the system. Said just to ask, whenever we design a system, we have to ask a question: Is my system fault tolerant? Is my system resilience? So when you ask this question, we'll come to know. Okay, no, now we have only two web servers. We have only web servers, one web server or one database. So in that time, we have to see to it that how I can make my system fault tolerance by removing all single point of failure. How I can make my system resilience by seeing that data is replicated, web servers are replicated, and the requests that are stored not just in database, maybe in cache. So all these things we need to think of when we design a system. Is that clear?
Yes.
Anything else? No, let's move to next concept. So let's talk about scalability. See, when maybe you have heard this term many times that your system should be scalable. Okay. So when we talk about scalability or scalable system, it's not just one component, not just database, not just web server. It can be anything. Any component in your system should be scalable. What does it mean? So I've just put a definition here. Scalability is the capability of system, process, or network. So here it is talking about anything. It's not just components, it's maybe a process, it may be a network to grow and manage the increased demand. As we have discussed earlier, if 1,000 users become 10,000, 10,000 becomes million. So in that case, your system should scale automatically. And whenever the demand goes down, your system should go down again. Scale, what is it called? Scale up and scale down. Okay, so your system should expand and contract. That is another word for it. So any distributed system that can continuously evolve in order to support the growing amount of work is considered scalable. So we already seen in just now when we were discussing uh, fault tolerance and as well as resilience, we have seen that we put our web servers under auto scaling group. So what is auto scaling group? Is automatically scale. More number of servers will be added whenever the system has a higher demand. And whenever demand goes down, there are minimum and maximum are always been there. So you will server numbers will go down automatically. That will be auto scaling, and it's same for even databases. We have seen slave databases and master database. So we have seen that, and that is important factor. It's not just applicable to databases or to web servers. It is applicable to any of your component in the system. We have to see to it that none of our component in our system is single point of failure, because anytime if that particular one component is down, your system will be down, and that is not acceptable, okay, when you design a system. So what we are going to look at here is there are two more these are normal concepts: horizontal scaling and vertical scaling. I put horizontal scaling first because this is what it is expected uh, when we design a system, and there is something called vertical scaling. So let's look at these. So horizontal scaling means scaling by adding more servers or more resources, I'll say, rather than servers. Because when you talk about server, it's not just server, but any of the component. So adding more resources to your pool of resources, it's called horizontal. What we are doing here, we have a machine, we have a web server. I'm just taking an example of web server. And if it is a single point of view, what we'll do, we will add more servers so that one server goes down, other will take care of the request. If other one is down, then next to it will take care of the services. So what we are doing, we are increasing the number of machines. And again, it depends on the kind of traffic that we get to your system. Maybe you need thousands of machines. There is a possibility, hundreds of thousands of machines, but it depends on how much traffic you get. And whenever suppose a weekend, there is a lot of traffic that you are getting. So you have to expand. So how you will expand? Maybe you will add more machines to serve your users. So it is called horizontal scaling. You are adding more and more machine with maybe same or different configuration. So that also possible. Maybe machine one will have a different configuration. Machine two will have a different configuration. And maybe it is, even though servers are there, maybe they are doing two different things, serving different users. So that is also possibility. But right now, what we're looking at is horizontal scaling at any level of the system. But here we are trying to see that how we can multiply a component depending on the requirements or depending on the traffic that we get. So what is horizontal scaling? Adding more machines, uh, increasing the number of machines. See, if you ask me, designing a system, you should have at least three machines at a time. Reason is if one or two get failed, third one will definitely take care of the system and your system will remain operational. Okay. But how the data replicated, how the request can be routed, all those things we have seen through load balancer, but we will get into more details later. And what is vertical scaling is scaling the machine itself. In the sense you have you, I think we all are using our laptop or computers. So we have some capability in our laptop. So suppose tomorrow I'm getting more requests, what I'll do, I'll increase my RAM, I'll increase my CPU or maybe storage. So that is when you're increasing one particular computer's capabilities or capacities, that is called vertical scaling. So I'm increasing RAM. Now I have 16 GB RAM. I'll shift it to 32 GB, later 64 GB, later 128 GB. So I can do that. That is called vertical scaling. It's a single machine, but what you're doing, you are increasing the processing power. So here I mentioned increasing. So that is called vertical scaling. That the same machine, it's a single machine, but you are increasing the power that used by that machine. So it's a just single server. So again, there is a problem in this case is that this will be a single point of failure. If any of the hardware in this machine goes down, then there will be downtime. So you have to make sure that whenever you are scaling your system, what kind of scaling capabilities that you will use. See, many times, no, people make when we are designing a system, they use a hybrid model of it. They combine both horizontal scaling and vertical scaling. How they combine? They will use a higher capability machines with higher CPUs, higher RAM, higher storage, and then they will have multiple such machines in their system so that both the things will be provided to the user or to the system to serve better to the our user. For example, if machine with higher capability is there, what we'll do, we will multiply such machines so that even if there is a single point of failure or even there is a failure, that machine request will be immediately routed to the other machine, which is again of the same configuration or maybe higher than that configuration. And there are sometimes we have different configuration also. It depends on how you want to design your system. But this is an hybrid model that I talked about, where machine is also with higher capacity and also there are multiple machines available with this higher configuration. So that is called scalability. And the scalability is more important. It is not just applicable to web servers or databases. It is to any of the components in a system. So you have to think about how you want to scale. See, scaling is important. It's just to make sure that your system is fault tolerance, your system is available, and also your system is resilience. See, when we talk about these concepts, definitely we are talking and thinking in terms of how we can make our system more and more available. And we have seen that if a system is not available even for half an hour for Google, we have seen that how much loss they incur. All right. So this is about scalability. Do you have any questions? No? Then I'll stop here.